Join me as I try to wrap my head around how time gets warped in space. It's going to be mind-blowing. Time dilation is one of the most fascinating concepts in understanding the universe. It's a phenomenon that has captivated scientists and theorists for decades, and yet it still manages to blow our minds every time we think about it. When we think of time, we think of it as a fixed, linear concept. We understand it through our daily experiences, our clocks, and our calendars. But what if I told you that time isn't as absolute as we think it is? What if I told you that time can be affected, warped, and distorted by gravity and speed? That's right, folks. Time is not always what it seems. As we try to reconcile our everyday understanding of time with how it's affected by gravity and speed, we're faced with a challenge. We're forced to rethink our assumptions, to question what we thought we knew about the fabric of reality. It's a daunting task, but it's one that has led to some of the most groundbreaking discoveries in the history of physics. One of the biggest hurdles we face is trying to visualize time in a way that's relatable to our everyday experiences. We're used to thinking of time as a straight line, but what if that line is actually curved, twisted, and distorted? It's a mind-bending concept that requires a complete overhaul of our understanding of space and time. As we delve deeper into the realms of space, we're faced with an even greater challenge. How do we measure time in an environment where gravity and speed are constantly changing? It's a question that has puzzled physicists and astronomers for centuries, and one that has led to some of the most innovative solutions in the history of science. Albert Einstein's theory of relativity revolutionized our understanding of time and space. He showed us that time is not absolute, but rather a relative concept that's affected by gravity and speed. According to his theory, time can slow down or speed up depending on the observer's frame of reference. It's a concept that's both exhilarating and terrifying at the same time. Let's take, for example, the astronauts on the International Space Station. Because they're moving at incredibly high speeds and are in a weaker gravitational field, time passes slower for them compared to those of us on Earth. It's a difference that's almost imperceptible, but it's a difference nonetheless. Imagine, for instance, that you have a twin brother who's an astronaut on the ISS. By the time he returns to Earth, he'd have aged a fraction of a second less than you. Time dilation has some mind-blowing implications for our understanding of reality. Imagine, for instance, that we're able to travel at high speeds for extended periods of time. Theoretically, it's possible to travel to the future, to experience time at a different rate than those on Earth. It's a concept that raises all sorts of questions about aging, identity, and our sense of self. As we look to the future of space travel, time dilation becomes an even more pressing concern. What does it mean for our understanding of time and space if we're able to travel to other planets, to other galaxies? It's a question that challenges our very understanding of reality and one that has the potential to revolutionize our understanding of the universe. So what have we learned about time warping in space? We've learned that time is a relative concept, that it's affected by gravity and speed, and that it has the potential to be distorted and warped in ways that we can hardly imagine. It's a concept that's both fascinating and terrifying at the same time, and one that has the potential to change our understanding of the universe forever. Thanks for joining me on this mind-bending journey through the world of time dilation. If you have any thoughts or questions about time and space, please let me know in the comments below. And if you want to learn more about the weird and wonderful world of science, be sure to check out my next video.